Welcome to Tech Photo Blog. This is episode number 4. This week I'm going to talk about the microphone sensor for the camera axe. So I think this is one of the most versatile sensors for the camera axe. It can be used for anything from a popping balloon to a shooting bullet to shattering glass. Just about anything that makes a loud noise would be a great use case for the microphone sensor. The different components I'll be using today are the camera axe, the microphone sensor, and a flash cable. Now you could optionally use a camera cable as well. That isn't as good for high-speed photography, but it works really well in the cases where you want to, take a picture of maybe something out in nature that's making a sound. The thing you need to take into account if using a camera is shutter lag, and I did a whole nother episode on how long shutter lags are. But today I'll mostly be focusing on flash cables, and therefore I don't need to worry about the shutter lag aspect. So now I'm going to show you the menuing system of the camera axe with the microphone sensor plugged into sensor port number 1, holding the activate button down while turning it on just to reset all of the values of the camera axe back to their defaults. Since I'm going to be triggering the device number 1, which will probably be a flash, from sensor number 1, I'll just leave that. The delay, it's basically the delay between the triggering and when the flash would go off. For a popping balloon, you might want to use something like 20 milliseconds. I'll just leave that at 0 for now. You kind of play around with that to get the shot that you want. When using a flash, the bulb is the amount of time between the first shot and the next possible shot. So 2 seconds means you won't accidentally trigger the flash twice consecutively by accident. Pre-focus, you want that to know when using a flash. The trigger type here, you can either have high, threshold, or low, and actually all 3 of those would work with the sound sensor because we're actually recording a sound wave with that sensor, and I'll show you how that works in a little bit, but most sensors need a specific setting. For the microphone sensor, any of them will work, but it will modify the trigger value here that you want to set. So you can see when I was quiet, the value is about, a little over 500, and when I start talking, it goes to in the 400s. So a good trigger value, if I wanted to trigger on my voice, would be 500. The power doesn't really matter. I'll just leave that on. If you wanted to turn off the power to the microphone, you could do that, but it doesn't really matter in this case. That's pretty much all you need to do to set up the microphone sensor with the camera axe. So here I've connected the camera axe to an oscilloscope, and the camera axe has the microphone sensor plugged into it. The idea is that I'm going to show on a graph what's happening to the voltage values being sent from the microphone sensor to the camera axe, and we'll plot those on the oscilloscope. So that loud clicking noise with my tongue created this graph. Basically, what this is the voltage. So this sort of middle line is about 2.5 volts, which corresponds to a value of 500 on the camera axe, and that's why that sort of when no noise was being made, we had a value of 500, and then when a noise is made, you can trigger off either a high value, and that would be up here, or low value, which would be down here. And I said that the threshold would also work, so that's the sort of difference between the high and the low. That's why all 3 values would work, and why the sound sensor is kind of a unique sensor. It's recording sort of this wave of voltages and sending them to the camera axe, and the camera axe is trying to trigger on either a high or a low or or the differencing of those voltages. So that's all I've got for today. I'll leave you with a few photos I've taken using the camera axe and the microphone sensor. Enjoy!